Okay, hi. For as a continuation to writing chemical formulas of ionic compounds, now it's the right time to continue it and let's start naming our ionic compounds. So we will be naming ionic compounds and particularly we're going to divide this into two again, binary and ternary ionic compounds. So let's recall when we talk about binary ionic compounds, we have a monoatomic cation and a monoatomic anion. So just it composed of just one metal element and one nonmetal element. When we talk about ternary ionic compounds, ternary are the ones which have polyatomic ions, whether cation or anion, which you need to refer to your list. What are these polyatomic ions? So how do we now name ionic compounds? So binary, how do we name binary ionic compounds? Let's look at the examples. So NaF, that's sodium fluoride. K2S, that's potassium sulfide. Ca3P2, that's calcium phosphide. Al2O3 is aluminum oxide. MgO is magnesium oxide. Now, what do you notice with the color coding? You notice that the red represents the metal and the blue represents the non-metal. And what do you notice with the red first? The metal. For sodium, it's just sodium. For K, it's just potassium. For Ca, it's just calcium. For Al, it's just aluminum. Mg is just magnesium. That means you notice that the metal's name doesn't really change. You just retain whatever is the metal you're dealing with. Nothing changes. But however, if you look at the non-metal, the blue, so fluorine becomes fluoride, sulfur becomes sulfide, phosphorus becomes phosphide, oxygen becomes oxide, and of course here it's still oxygen, it becomes oxide. So there's only one rule for naming binary ionic compounds, and your metal has only one oxidation number. It's just that you just have to make your non-metal ends in IDE. So some metals are presented already in the examples of fluorine fluoride, sulfur sulfide, phosphorus is phosphide, oxygen is oxide, chlorine becomes chloride, bromine becomes bromide, iodine becomes iodide, your carbon becomes carbide. So these are some of the examples of your nonmetals. So basically, it's not dependent on whatever is the value of your subscript. All you need to do is just make your nonmetal's name ends in IDE. So it's not dependent on the value, but just make the name end in IDE. So that's how simple it is to name binary ionic compounds. Let's now go to naming your ternary ionic compounds. So when you name ternary ionic compounds, again, you need to refer to your list for the polyatomic ions. And for this example, if you have NH4Cl and from your list of ions, NH4 plus is named as ammonium, so ammonium's name is retained. And since it's a monoatomic nonmetal chlorine, so chlorine has to become or has to end in IDE, so it will become chloride. So it's the same as the binary ionic because you're dealing with a monoatomic anion and it's written second or last. That means you need to let it end in IDE. However, if your anion, for example, this, if your anion is, or your ion is an anion and it's polyatomic like this, so you have Ca2 plus and NO3 negative. So when you crisscross it, it will now be CaNO3. Actually, this is CaNO3 parenthesis 2. Sorry, there should be a parenthesis 2 after NO3. But when you name it, you retain the name of calcium. So Ca is still calcium. But for NO3 negative from your list of ions, it's named nitrate. So it doesn't change. So you just copy whatever is the name of the polyatomic ion. So nitrate. For chlorine, because this is not polyatomic, so you make it end in IDE, chloride. But if again your anion is a polyatomic ion, is a polyatomic anion, you just have to retain its name. So nothing changes for calcium nitrate. And again, make the correction, there should be parentheses enclosing NO3 here and you put 2 outside. Now for magnesium, And hydroxide, when you crisscross Mg2 plus and OH negative, the resulting chemical formula is MgOH2, and Mg is just magnesium. You don't change the metal's name. And hydroxide, OH from your list, is named as hydroxide. So the final name is just magnesium hydroxide. Nothing changes. Now, for this, NH4 and NO3, these are two polyatomic ions. So you have a polyatomic cation, ammonium, and you have NO3 negative, which is nitrate. So these two, that's NH4 plus and NO3 negative, we crisscross it. This is the final chemical formula. And so when you name it, because both are polyatomic ions, nothing changes. Just copy its name. So that's ammonium nitrate. So ammonium nitrate. That's the final name. Similarly, if you have ammonium and phosphate, when you crisscross the two, it will become NH4 parenthesis 3 because again it's not 1 and it's a polyatomic ion, so you need to put a parenthesis, and then PO4. So the final name is ammonium phosphate. Nothing changes. Now let me focus on the example that I did not discuss yet. This is iron and iron 2 plus and SO3 2 minus, which is your sulfide. Now iron is not an S nor a P block element. It's a metal that belongs to the transition metals. Now I will give a special discussion on that. These are what we call metals with variable oxidation numbers. Now when we say variable, these are metals with more than one charges, more than one oxidation numbers, and usually these are the metals in the D and F block. We will just be dealing with the D block for simplicity. So the D block elements, these are like iron, copper, lead. These three have more than one type of oxidation number. So depending on what you're using, these metals with variable oxidation numbers has a way of naming them. That means you need to watch out for these metals. How do you know? I've placed that in your handout. The metals with variable oxidation numbers are on the left column. So you have to be familiar with them also. So iron, for example, can be Fe2 plus or Fe3 plus depending on the use and depending on its name. There are two ways of naming the metals with variable oxidation numbers. The way is either you use the stock way, the stock name of naming, or the common name. The common name is using its old name, like iron came from ferrum, and so you use OUS ending if the oxidation number is lower or lesser, and you use an IC ending for the oxidation number that's higher. Or you may choose the easier way. If you're not comfortable with a common name, you may use the stock name. So just use the name of the metal, the name in the periodic table, and inside the parentheses, you just put the Roman numeral value of the charge. So if it's a 2, the Roman numeral 2, you write it and close it with parentheses. So that determines that the iron you're using in that FeO compound is the iron 2 plus, not the 3 plus, because oxygen is always 2 minus. Therefore, for you to arrive at FeO final chemical formula, Fe should also be 2, so that the 2 and the 2 will cancel out. So when you name FeO, you don't name it just iron oxide, but you have to emphasize that it's an iron 2 oxide, or the old name is ferrous oxide. Ferrous is the Fe2 plus because ferric, if you look at here, ferric is the Fe3 plus. There are two charges for iron. It can be 2 plus or 3 plus. The 2 plus will have OUS ending. The 3 plus will have an IC ending. So if it's Fe2O3, obviously the 3 came from Fe3 plus, the 2 came from oxygen, which is you know that oxygen can only have 2 negative. So therefore, the name of this will be iron 3 oxide. So same thing, huh? It's IDE ending for the nonmetal. Iron 3 or ferric oxide. Similarly for CuI2, that's obviously Cu2 plus, so you name it either copper 2 iodide or cupric iodide. If it's Cu1 plus, then that becomes cuprous iodide, and that's copper 1. For lead, it's Pb2 plus and Cl negative, so that's lead 2 chloride and plumbous chloride. So that's it. Remember that you just have to look out for these metals with variable oxidation numbers and you'll be successful.